And for a board meeting, so I'm staying at my parents' place. And for some reason, no matter what they do, their internet is shitty. So like they replace everything. They replace the router. They have service. They have my brother look at it, and their internet is always shitty. So, okay. I'm just going to leave it in this mode so I can go between slides. Is that okay for people? Can you see the main slide
Yep, that's
well
fine.
enough? Okay, so just a reminder why we're using an agent-based model. Statistical data tells us what we can do, but it does not tell us how fast. And that's a thing I'm interested in. And it's a thing we should be interested in because of understanding transitions. So the agent-based model is an example of a time-dependent model. People often use it to simulate interactions between agents like buyers, contractors, and people's peers. We're not talking about that here. In what I'm talking about today, we're using it only to simulate the time dependence, and we can get to the other stuff later. And so we looked at a bunch of ways of representing dynamics, and we decided to go with the ABM. And I would say we're still in the very basic process of developing it. So you heard Narasimha talk about a two-stage decision model. I'm going to expand that to 3 stages. The first one is the consumer becomes willing to engage in a decision, like not being able to avoid replacing the heating system. And then the second one is when the consumer decides what they're choosing between. Sometimes decision model, you've been looking at 1 and 3. But so now that I talk about 3 stages, the former 2 stage was the first and the last. And I'm going to step through each of those and ask Raidul to come in at the times when he is ready. And so also just for context, what we're talking about today, we're hoping for Raidul to write a couple of papers in the next couple of months. And the first one is just rates of change in Colorado, who's being affected, with fairly standard influences. We're not going to do anything fancy. All the stuff that we'll talk about today probably won't be in the first paper. And the reason is we've been noodling around for a while. We just want to have a basic baseline paper to emphasize the development. In the second one, we will look at rates of change in Colorado with expanded influences that everybody brings forward. And so I'm hoping that the discussion today will feed into what we're thinking about setting up like the second refined product. So if you don't see what you're proposing in the first paper, don't say, hey, you ignored me. We're just doing it a step at a time. Okay. So the first decision rule is that the consumer enters the decision stage. I am deciding that I'm going to replace something this year. Currently, it is the equipment reaching the end of life, not just the heat pump, it's a furnace or heating system. That's misstated. On Wednesday, the modeling group suggested that Christina was seeing that happens during a change in occupancy. We talked about using some of Ryan's permit data to get a hazard rate. And so that's on the table. And Raidul, do you want to say anything about how you're representing the decision, this first stage? I don't, yeah.
Yeah, I can elaborate later, but the idea is that, and this kind of straightforward, Tammy has an inventory estimation, like depending on the vintage year and existing equipment categorization, what is the age distribution of existing HVAC equipment. So basically the model runs from say year 2023 and find out what is the current age for the equipment for an existing household, and whenever it reaches the end of life, those households will get into the decision making process that okay, now I have to make changes at home. So for now, the straightforward decision stage one.
So then this blank with others is things that this group could bring forward. So I'm going to run through 2 and 3, and then we can go back to any of these and hear your ideas. So the second one is the consumer selecting a choice set. Now, you don't often think about yourself selecting a choice set. You just go, I'm choosing between this and this. Like, these are my two options. And how you winnow down, right? Like, I decided I'm not going to buy this. Sometimes it never even rises into your consciousness. Um, this is not currently, we decided 4 options. And what's possible is that we can make it so that the contractor education determines the choice set. For example, contractors are not offering heat pumps unless they're educated. Um, so then there's a role for us to fill in. So everything under currently is what we're doing now. The first paper you're going to see, but we want to open up the discussion because everybody has experience to throw into paper too. Oh, I should stop and ask. Let's see if there's any questions. Okay, and then, so in the third stage, the consumer selects one of the choices. And I'm going to go into more depth in this and in the later slides. But the modeling team in our discussion on Wednesday suggested maybe we want to consider prior equipment. And then Christina uses a random forest model and another technique that I can't remember to determine important factors and gets probability directly. So let me talk a little bit about that probability before we go on. Here's your choice set, and these are just examples, but let's say that you have 3 choices, A, B, and C. And there's each agent has a probability of choosing one of them. Those probabilities of choosing have to add up to 1 because you're going to choose something. You're not going to choose nothing. So the hard part is getting those probabilities. So on the last side, when I said Christina figures out what's important, she gets current probabilities based on identifying what variables are important. And then there's some, honestly, statistics I don't completely understand, but she would come out with a probability. What Raidul is doing right now, and please jump in anytime, is, and this looks complicated, but it's what an awful lot of people do. So it's a multinomial logit. This is the equation where you put in the utilities of option A, B, and C. I'll talk more about utility in a little bit. These 2 equation forms are equivalent. And utility is a big fuzzy thing that is sort of like, how much is it worth to you? I'm explaining this badly. I'm sure an economist would do a better job, or Kartik or Ryan would do a better job. But this is the way a lot of people do it. They calculate utilities for each option, and then this equation automatically makes it so they all add up to 1. And people often represent utility as linear, could So it's got a coefficient and a value, a coefficient and a value, coefficient and a value, then you always end up with some error. It could depend on features of the option, the thing being chosen, like cost. It could be dependent on the agent that is choosing. So all that stuff gets packed into here, and then you plug it into that equation. So even though it looks complicated and weird, that's just an extremely common thing to do. Okay, so now, Raidul, I don't know if you want to show what your current inputs are, because I know you had a presentation. I can stop my share and you can show yours. So I know not all of you are modelers, and I just wanted to give you some background on how we're doing things, other ways that people might do things.
Yeah, so Tammy mostly covered the overall uh, mechanism of what we are trying to do. I'm getting into like more technical or nitty-gritty things. Like for example, what are the data set we are using for the ABM model to inform the household categorization, how we are leveraging those data set to build the decision rules, and how we envision, like in the future, if we get into more decision rules, what are the data set we are trying to take advantage of. So the current ABM model has the ability to extract data set from association data that Karthik and Narsima developed. Zara has developed a building object data set that gives us an estimation of the energy requirement depending on unique values for household area size, and also different price variabilities for fuel used for HVAC system. And Tammy has provided an equipment inventory data distribution that give us an age distribution for the uh, household level equipment system. Uh, so we take all this of data set and we are being able to create the whole Colorado population of say for like 2.4 million Colorado households that have unique uh, attributes, set of attributes that include vintage year, income, household area size, existing heating equipment, and operating and installation cost. So uh, given all these variables are integrated at household level, the ABM model initiates the decision-making process. For now, we are only considering a two-stage. The thing that Tammy has shown that three stage, that's something I envision to do in the future. But for now, the ABM kind of operates on a two-stage decision-making process. So we first identify which households are getting into the decision-making sphere, and that is triggered by the age record the age of the existing equipment. Whenever the life cycle of that equipment ends, it's run, they will trigger that, okay, I have to make changes at my home. That's the first thing that is triggered. And then there are some specific decision rules that we introduce to the ABM model that supposedly constitutes of how people think when they are making that decision or selection of heating system. And we are now considering that people will be choosing between these four different heating system, four-stair furnace, natural gas furnace, heat pump, and electric baseboard. That is based on our understanding or uh, engineering judgment that something may evaluate in the future, constrained by contractor suggestion or availability of technology in the market. Uh, the current decision variable or that constitute that decision rules, we are considering three different decision variables. The first one is the total cost that includes the installation cost and operating cost. Basically, the idea is that households will choose the lower cost option between among the option they are being provided with. And secondly, one is about the vintage year. Like for example, new households uh, especially built like after the year of 2000, they have the infrastructure ability to adopt newer energy efficient appliances. So they are more likely to adopt heat pump system. The third one is like building type, like single family detached households, as I have seen in the literature. but take into consideration that those literature are mostly concentrated in Europe market, so there may be some biasness. So the idea is that single family detached households have more control over what decision they are going to take. And so they have the flexibility to make changes at their home in a very quick amount of time. So they are more likely to install energy efficient heating system in their households. So these are some of the decision rules we are currently implementing in our ABM model. And of course, I'm open to any feedbacks and suggestions, or if it doesn't make sense or something like that. But this is something the model currently trying to replicate. But the most important feedback I'm trying to get from all of you is that what are some of the more realistic decision rules can we introduce based on what we have been doing for the last 2 years, that may come out in our second or third paper. But the idea is that whatever decision rule we can think about that has to be quantifiable, meaning that that may have some quantitative values in either Karthik's data set or Sarah's data set. So they are also here to provide answers to. So that's kind of where the ABM model is now. Yeah.
Right, I have a question about, yeah, these decision variables. So do you think there's a way to either validate or calibrate some of these choices? Like how do you justify, or you said, that this is available in existing literature. So is that the fallback, or is there a way to somehow validate this in a more, quantifiable way?
So short answer is yes, there's a way to validate like the results the ABM model is producing. We can easily like calibrate the model parameters or the decision rules that we are introducing, and it can take and then run for the future year. But at this current coding architecture, I have not implemented that yet.
I
Well, but
see.
we're making it match what's out there now.
Yes.
So, but that's always the problem is always that you calibrate it based on what's existing, and then you kind of hope that what you infer about the future is is going to be accurate. And so obviously it has to match what's out there now.
Mm-hmm.
And the way I've done this in the past is just tweak the parameters until like and then run it over time so it matches the trend over time.
Mm-hmm.
But there's a whole lot of uh I wouldn't say black magic, but it's like that you can get the right answer for the wrong reason.
Right. Okay. Yeah. Okay. That makes sense.
So yes, it has to look plausible. And so it is in that way grounded, but it's not, yeah, it's not it's not great. So I think we're fighting with the it's not great. Ryan's got a side conversation here. Um yes, you can model things as individual probabilities and not discrete choices. And I believe that's what Christina is doing now. So you already know the probability of something being chosen because it's in the building stock. The the so there's no reason to go to that complicated equation. The reason that people do it is that they hope to model what happens if something changes. So you kind of want to know, this is what I've come to, you kind of want to know the influence of different parameters individually. Um, Ryan, I don't know what ergum is. You can talk also.
Yeah, I just like, I'm a chat warrior. I don't know. It's easy to type things. Then I remember what I'm going to say and I don't just talk.
Yeah, that's a good idea.
Like
Um,
I understand your point, but I also think like anytime someone's doing a multinomial logic, logit model, I get scared because like there's all sorts of assumptions it makes about that choice set. And like replaceability and deleting a choice and other choices becoming more relevant and less relevant. Whereas like if you model each as an individual outcome, and so like an ergom is just like a network model. So you could think about like people being networked to heating systems and they have like, you know, 0.25 of a gas furnace and 0.75 of a heat pump. That's not actually going to be that worse as far as predictive capability. You're just not going to throw
Mhm.
them to one or the other.
Mhm. So I'm not, as I said in the modeling meeting, I'm not married to the multinomial thing. As long as there's something that we can create that allows people to choose. That's what we're using right now. This is a little bit of a cop out, but it's defensible because everybody does it.
Yeah, no, that's fair. Like,
Um, right. It makes you not have to fight reviewers. Um, even though it's just as bad as everything else. There's a bunch of stuff like that. So today we're using that. I think it, I would be open to other things. But so I think the point here is that we're really seeking the probabilities. And if we choose to include more things in the model, we have to have a way to get the probability. I don't care what it is. So one of the things that was not on the list was heat stress, which Chris has run into again and again. Right. And so that would be a thing to think about. How would we include heat stress in that model? Another thing is what you've come up with, Ryan, where you see that people are putting in heat pumps in the summer when the need for air, it's similar. So they're responding to heat, not to electrification. And so Raidul's running this quarterly. We can make the rates in the summer be more favorable to heat pumps if we get data from you, for example.
I think that'd be really straightforward to do, actually. That's it. I'll write
Yeah.
that one down.
So maybe other thoughts are totally welcome now. The reason I presented it in this framing, like here's how you model, is so we don't have a conversation that's like, yes, let's do all this stuff. It's really important. And then we actually have wait. Now, I'm not expecting you to have an idea of putting it in the model
I'm not able to
when you come up with it, and then 3 steps at which to do it. Set, and then choosing among the choice set. It could be represented as any of those.
For me, that did not come through clearly. I don't know if it did for others. The sound was broken up, so I don't. But maybe it was fine for others.
Can you hear me now?
Yeah, I
Yes.
can now, but
Okay, so I'll just repeat the very last thing I said. Okay, so we need a way to define the probabilities in each of those 3 steps. They can be creative, but we need to end up with a numeric probability of making a choice. That's the fundamental thing of the ABM. And it could be introduced at stage 1, getting into the decision phase, stage 2, deciding on the choice set. Stage 3, deciding among what choices you will make.
Okay.
Tammy, within stage 1, do you all have the building stock like constraining the individual choice set, or is it just is it like existing building stock blind? Does that make sense?
Each building knows what equipment it has, how big it is, and what kind of building it is.
Yeah.
Does that answer your question?
I think
So
so.
you could do, it would be easy to put in prior equipment. Kartik, one of the things I want to talk to you about is bringing out in the existing data, whether they have gas cooking and gas water heating. I don't know if that's possible, but that indicates whether they've got a gas connection, and I think that's important.
Let me check. I think so, but let me check right now,
Oh, you
actually.
guys all froze again. Or I froze. Did you hear me?
I think I'm hearing
Yes.
you still.
Okay. Okay, I just saw the videos freeze. Yeah, so this is an iteration, right? Christina finds out that prior equipment is important. Sometimes it's not exactly the prior equipment that's heating, but it could be that if you have a gas stove, that means you have a gas connection, and then you have the infrastructure, and so you're more likely to choose a gas furnace because gas is cheap, and there it is. But then we need to go back to Kartik's data, generate the correlations so that Rydul can sample from them. I guess so yeah, go ahead. Maybe just throw out stuff that you think is worth exploring, kind of low-hanging fruit for we've seen that this is important. Now can we come up with a creative way to model it?
I think it would be I don't know exactly how to do this, obviously, but thinking about not just like contractors and what they're providing, but like the choice set of contractors. One thing that sticks out in Chris's data is like everybody's relying on the same contractor, which is really different than our Denver data set.
Mm-hmm.
And that adds a lot of complexity, and I don't know. I don't know how it integrates in the model, but I suspect it matters.
Yeah. Yeah, I don't know how to do that's probably worth a whole discussion on its own, right?
Because like my hunch is people are sorting contractors based on the technologies they're curious about as well. Like if you want a heat pump, you Google contractor heat pump Denver,
Mm,
directs you to a different contractor than if I search furnace
mm.
Denver, because how Google search works. Also, like if we think
Wow.
people are attracting contractors in their neighborhood, like based on who they know, we might actually expect neighborhood effects. That was one of the reviews we got on that Pueblo paper that I need to respond to still. But I don't.
Mm. Yeah, so broad question, how would we represent contractor effects?
Could it be gated? Ryan, where like, because right now your model is just set up with the choice set being for fuel stove combinations or whatever, heating, appliance energy source combinations. It seems like you'd need either a layer or a gate
Mhm.
that would And that might simplify the choice set in that if you could get the choice set on contract, if we think that happens first and you get the choice set on contractors, it would limit the choice set on things. I think probably what you were getting at, Ryan, is it's hard to tell which comes first if they're,
Mhm.
if they have a trusted contractor and they're gonna go with the choices that contractor provides them, or if they have a desired energy combination and they're gonna look for contract, like that does. I don't know that that's known in terms of sequential. Or it would be known individually, but whether it could be determined.
Yeah, I think so. That's not that's quite possible to do in an ABM. I won't say anything's easy,
Mhm.
but that's part of the reason we went with it. It's that that kind of interaction is easy to do, but getting the information is hard.
Mhm. Yeah.
If I had national data, what I'd do is I'd see if you could like fit like a HHI, so you have like market density, and then see just how that correlates with like variability in the choice set. But I haven't
What's
seen national
HHI?
data that could do that. Like it's like a Hirschfeld index. It's what economists use to see if there's a monopoly. So you could take a market and you could say, is this a monopolized market, or is this a like a whatever it's called, non-monopolized market? And then how relatively monopolized is it?
Mm-hmm. Mm-hmm. Yeah, I wonder, so we're near the end of time, but it seems like I know we keep coming back to the contractors. Um, and it seems like it's worth spending some time figuring out how to represent that in a model. I I hesitate to say model everything because but I feel like a model is a way of saying of trying to convince people like how important could this be? Now, I don't like if you have no information, is it oh, I'm sorry, Ryan. Yeah, go ahead. Um so general idea, the place that I'm always in, I think this group is always in, is like, okay, it's really hard to represent um things that actually happen because we don't know how likely they are to happen. And yet what's happening now is that people are just ignoring it because they don't know what to do with it. So finding that happy medium between where you ignore it and where you are overly confident in your results is is a challenge.
So I had a quick question, maybe 1 or 2 minutes, and maybe for Karthik and Chris, maybe. So one thing I was really excited about, and like that heat stress, or like, do you see, is it quantifiable, or is there any data set you think there is to introduce in the decision stage one, that okay, for now we are just focusing on the equipment age distribution, but as we have seen in the literature or in the survey too, that heat stress is something that will push people for making changes at home. Is there any way to quantify that? Do you see?
Wait, are you
From the
saying, oh, sorry, go ahead.
go on, Alison, go on.
Is the question you're asking is there available evidence for as people are experiencing more heat stress, there's evidence that that's associated with making more decisions about cooling?
I'm assuming based on what I have heard in the discussion, there is evidence, but my question was that, is that quantifiable, or is there any variable to capture that effect? And feel free to let me know if I'm wrong in the first statement as well. Like,
No, I don't think you're wrong, and I think you could find numbers in papers that I think the um
Yeah, from the data perspective, I've seen sort of proxies like not having air conditioning in the house, or your air conditioning equipment being broken, or number of days you didn't have air conditioning in the house. So I've seen things like that being used. I don't think we have any subjective variables in the data set for heat stress. So we have variables for the other ones. So for example, we have variables where people say they're like too cold in the house during the winter, but I don't think there's any equivalent of that in the summer. So there's no subjective ones as far as I'm aware, but there are a lot of, you want to call it, objective proxies for heat stress that people use.
Okay, yeah, I'll discuss with Tammy then and get back to you all.
Mm-hmm.
Yeah, but I mean, I realize that we're probably not going to meet as a group for a while, but maybe it would be good. We're going to go forward with that with the ABM because Raidul is going to be around for another few months. So I think it would be great if we continue to occasionally check in about stuff like this, because I feel like the promise is in bringing it all together, right? Not in, yeah, the promise was always integrating it. Okay, thanks, people. Have a good weekend. Nice to see you.